Welcome back to part 2 of my VoltX battery teardown and review. As promised from the last video, I will attempt to parallel these two batteries up. I'm also going to talk a little bit about what I found out about the cells and the BMS, and generally my overall thoughts now after mucking around with these batteries for over a week now. Just to, it's probably important to find out whether you should spend your hard-earned cash on, some cheap Chinese battery. Right now, so I've got it joined up, negative to negative, positive to positive. I've got my clamp amp meter around the negative cable, and I've installed a manual reset circuit breaker, electromechanical type. I've got my oscilloscope hooked up to each battery, so the voltage on the right is the right battery, the voltage on the left is our new battery that's turned up. Now, interesting to note that I've charged this battery up, and compared to this battery, it's charged up a lot more balanced than what this battery did. After completing the load test on the battery, this cell still failed to charge up properly. This one maxed out, and these two sort of sat around the 3.4 volt mark. This has got up to 3.7 volts, and this one stayed at around 3.3. Now, 3.3 is a sort of nominal voltage of a lithium battery. So running your cells at around 3.3 volts would equate to your battery being around the 80 to 90% capacity. Nothing wrong with that, and that's probably about where they should live. Ideally, you don't want to charge a lithium battery to full capacity all the time. You're going to end up not doing it any good. Now, ideally, every 3 months, and they say this in all the instructions on the batteries, is you need to charge your lithium battery fully. Now, the lithium battery, depending on your BMS, will depend on how you should do a full charge. Now, we'll talk about this BMS briefly. Now, from what I've been told, these batteries don't have any over-temp protection or anything like that, so they can just run away and burn out if you're drawing excessive current. That's why you've got to really limit your current flow to, or current draw, I should say, to that maximum of 50 amps, because it's possible that without really knowing much about it, the temperature setting on it, but from what I can see, it doesn't have any, so you're going to run into a bit of strife, possibly get the thing red hot. I haven't had any trouble so far, but the passive balancing side of the BMS is pretty crap. It does about 50 milliamps, which is really low. Now, it does do passive balancing, but at 50 milliamps, it's really hard to get that passive balance to work. If you're charging this with a 10, 30 amp charger, it's got to dissipate 50 milliamps off this cell here, and you're trying to push in 30 amps into the battery. It can't balance, and it's going to overcharge one cell if the cells aren't matched, which is exactly what it's doing. Now, this BMS won't balance until it cuts into the cell voltage gets to 3.5 volts, and above, it'll start to balance. Now, what's it mean by balance? Balance means it'll switch on and start to draw 50 milliamps off this battery to draw the voltage down to allow the others to come up. So now, as you can see, we've got 13.46 in one battery, 13.8. We'll zero that. Probably won't zero much more than that. And zero current flow. We'll flip our circuit breaker and see what happens. As you can see, this battery here is putting in current. You'll probably see the voltage maybe start to drop as the batteries equalize. Now, if these batteries were at very different voltages, you're going to have quite a lot of current flow. A little bit on the cells on these batteries. Now, after having a bit of a try and search on the internet, just by using the actual measurements of the cells, I found out they're probably around the 110 amp hour, 120 amp hour cell, which would explain, them being a huge cell. They're probably at 80% capacity, which when you reach 80% capacity of a life capacity of a cell, you pretty well, the cell's had it. It maybe have a year or two left in it from what I can understand. Now, this is probably a way, these batteries are probably a way of China not dealing with recycling lithium cells. I believe it's too expensive to really recycle a lithium cell compared to a lead acid battery. Now, the materials, other materials that go into making a lithium ion battery are recyclable, but the lithium itself isn't viable to recycle at the moment. It's actually more expensive to do that than actually make lithium. So that's, that in a nutshell. You're getting a used cell that's pretty well past its date, from what I can guess. It still does its amp hour rating. There's build quality is good. The BMS is very, very average. This BMS retails for around about $12 Australian. So, an average good BMS would probably cost you $60 odd, I guess, if you wanted to rip that out and put that in there, just to make the batteries last a bit better. Is that something I should do? I don't know. I'm going to run these batteries as they are, to see what happens. Like, this is what a normal person would do. You'd buy these batteries and you would use them. Now, the warranty probably isn't worth the paper it's written on. That's why I haven't been too concerned about cutting these batteries open. We'll go back to sort of having a look at what's happened here now. The cells are very close to becoming matched in voltage. Almost zero current draw. There'll still be current shifting between the batteries at that, but it's getting very close. I'll leave these until the actual voltages match, and then I'll put my charger on, like I said. So my view on the batteries, should you actually purchase these? You really got to look at what you want to do with the battery. Now, the issue with most people who are coming into lithium batteries now is the overall setup cost. Now, just to buy a lithium charger, DC to DC charger, you're looking at between $400 and $500. A 240 volt charger, you can buy cheap ones, yes, but you're probably looking at between $300 and $600, depending on the size of your battery bank that you're going to be using to charge. Now when I've done setups before, you're looking at $1,000 worth of gear plus wiring, time, $2,000 easily to go through and set up a van for lithium, and that's probably a little bit on the low side maybe. And then you've got to add the cost of, like, the average 100 amp hour lithium battery is around the $1,000 mark for what I would consider a reasonable lithium battery. So this makes it really hard to make the shift from AGM to lithium. Now, is there anything wrong with AGM? Nothing at all. They all say that AGM, you can only get 50 amp hours out of a 100 amp AGM battery. That's rubbish. A new AGM battery, you'll get 80 amp hours out of it. But you got to expect, like anything, it's a consumable item. If you use your batteries hard, regardless whether it's lithium or AGM, they're not going to last. Yes, you'll get more cycles out of a lithium battery, but you've got that big cost expense to get out of it. The main advantage I can see over lithium, besides the weight, is how quickly they charge. You can charge these things back up to 90% really quickly, depending on the size of your charger. I guess the question I'm trying to answer is, are these batteries any good? Well, they're safe. I don't think they're going to blow up in your face or burn your van down. Are they any good? The answer is, it's going to be hit and miss on the cells, depending on which battery you got. This battery has got crap cells in it. This battery actually has fairly well matched cells. So, you're going to be limited to the luck of the draw. I'd be quite happy to purchase one and, and expect nothing more than maybe a year out of it. But I'm also going to maintain these batteries properly by actually putting as I've said before, a balance port in here so I can use my lithium cell charger to charge the cells individually to bring them back up. That's not going to stop an individual cell from failing. I think this cell here on this battery is pretty well had it. It doesn't want to stay at a fully charged point. I've charged it up to sit at 3.6 volts, and then I'll leave it for a couple of days and it's back to 3.3. So that gives you the answer that there's that's something wrong with it, where the other cells will stay at 3.5 quite well in this battery. Right, I'm not going to bore you anymore with this. I'll put my balance ports in there. I'll install it in the van, and we'll call it quits. And hopefully this was of some help. But honestly, if you've got the extra dollars, go buy yourself a good quality Australian company lithium battery that that are good. Now, there's Australian companies that are selling lithium batteries, but they're still assembled in China. So it's going to be the luck of the draw and their overall quality control. The other thing to remember is batteries with Bluetooth monitoring in them, don't go there. The Bluetooth circuit draws power off the battery, and when your battery's sitting in the van, it'll actually discharge the battery, and you've got no idea that it's actually doing it because it doesn't monitor that discharge out of the battery. So it's more of a gimmick. It's nice, but not worth the extra money to pay for. Just accept that it is a usable item that is going to wear out over time. If you get 7 years out of 5 to 7 years out of a good quality lithium battery, I'd be happy with that if you've worked it really hard. And looking after the battery is the main thing. Charging it correctly. Talk to the supplier about how you should charge it, what the limitations are when you come to charge it, and you'll be right, and get the actual required life out of the battery. One more thing is, if you've got 200 amp hour AGM, replace them with 200 amp hour lithiums. Just because someone says that a 100 amp hour lithium will replace 200 AGMs, yeah, in theory, but it doesn't work that way. You're going to be flogging the battery hard if you require that amount of power. So to put an ending to this test, the batteries are very well assembled. There's nothing wrong with the quality of the battery. I believe they would be safe enough for you to use if you use them in their limitations. So if you parallel them up, remember to keep your current draw below 50 amps, and I don't think you'll have an issue. Should you really go out and purchase these batteries? If you're doing a new lithium setup in a van and you want to buy good quality charging gear to charge the batteries, but the budget won't extend to buy yourself $2,000 worth of lithium batteries, if you need 200 amp hours worth, then I would put these batteries in and run them until I can afford to buy a decent battery. And if you only need one, put one in. But they will do the job for you. If you've got existing lithium batteries, I wouldn't replace them with an existing lithium battery just because they're cheap. They're going to be hit and miss on their quality. The cells aren't matched, which is an important thing. If you read on any other lithium manufacturer's website, they'll say that they use A-grade matched cells, and that's what you're paying the dollars for. That and a quality BMS that's going to manage the batteries better than what the one in this does. This will do it, but not very well. If you don't take the time to do the things that I said, I believe you're going to run into a battery that's going to die on you. So yes, the batteries are safe. They're well built, they'll do their job, but their reliability probably isn't where it should be. You're not going to expect to get 3 years out of these that the warranty says. If you're going to use them hard, no way in the world. The other thing they'd be great for, if you've got a trawling motor in your tinny and you don't want to lug around a heavy AGM, hey, that'd be awesome. You know, they'll do that well. I'd probably keep some oars in the boat. Only joking. But so I'll keep you updated on how they go once I install them in the Vista at the back here, and we'll see what happens. It could only go bad.